Hello everyone. So let's continue with the course. So now we're gonna do the scattering part. So we are gonna take the wall and we're gonna instance some points. And then we're gonna instance spheres into that points. And these spheres will be in charge of fracture our BDB. So I like to, during the process, create this UV quick shade node to know that, okay, in this part, the UVs are okay. Okay, so let's take the wall and first let's create a BDB from polygons. And here we're gonna mark the option of fuck BDB density. And remember that you have to decrease the number to achieve like a very detailed result. Something like this. Then we're gonna create a scatter node. When scatter, we are gonna switch off these options for this one and the relaxed duration, and we're gonna use only the density scale to create more or less points. If you press the middle mouse button, you will see the number of points. So once with these points, if you press this icon, you will see that you don't have normals. So we are gonna have to create the normals. So we create the attribute Bob, and we are gonna create like a random normals. So the spheres are gonna be copied like randomly. As you can see here, it's like the normal is random. So if we get inside, first of all, we have this setup. This is very easy. So we're gonna take the PTNum. So it's the number of each point. So then we're gonna tell Houdini that we want the PTNum like randomly. So every point is gonna be like a random number. And then we're gonna create like a fit. This is gonna be like a 3D vector, and the source max is gonna be 1 and the destination mean is gonna be -1. So with this we are gonna create like a 360 like degrees of rotation. Then we're gonna normalize. So we're gonna tell Houdini like this is a normalized vector from 0 to 1. And finally, we're gonna bring this into the normal. So super easy. So with this, we're gonna have the random normals. And finally, we're gonna create an attribute wrangle in points. And here we are gonna create the p-scale. So we're gonna tell Houdini that each point will have one p-scale different. So then we're gonna transfer all this information into the spheres. So once we do the copy, each sphere will have the point p-scale. So we will have like a big or small spheres. If you press Ctrl B on the spreadsheet, you will make the spreadsheet like full size. And here you will see the p-scale number. So here, first we have created an F, so which means a float, because the p-scale is a float number which has like decimals, like 0.1, 0.2, 1.3, and then we are gonna create the name of the attribute. In this case, I recommend you to do not change the name and use the p-scale because it's like an inherent attribute in Houdini. So then we're gonna tell the expression of the p-scale equals, and then we're gonna create the expression fit 01. So we're gonna remap, and then we're gonna tell Houdini that this is gonna be like a random. So we're gonna use the rand function. So if you don't remember how this expression works, if you put over the rand and you press F1, automatically Houdini is gonna open the documentation. So here you can refresh your knowledge about this expression. I always work with this open because it's very useful. And then we're gonna tell that we are gonna use the rand function in the ptnum, so in each point. So then I create like a channel float, because then it's like you will be able to use the parameters like easier. And here you have the min and the max. So once you put the semicolon, just press this icon to create the parameters and just play with these two numbers. So let's see what's going on with the spheres. So first of all, we have created the sphere, and this is a polymesh, and we are going to increase the rows and columns. Actually, we increase the uniform scale, and we create a remesh. I like the remesh because very easy. Houdini is like creating like a triangular mesh, and it's gonna be like faster to generate the noise. So here, instead of creating a point bob in order to create the noise, we just create a mountain, just because I'm gonna show you another ways to create the noise, because in Houdini you can do the same thing with a lot of different ways. So use the one that you prefer. So once with this, we copy the spheres into the points. So, and we will see that our spheres, each sphere is copied randomly in each point. And now if you play with these numbers, you will see that our p-scale is working. So now if we increase or decrease one of these numbers, you will see that some spheres are going to be like this size and the other ones are going to be like bigger. So just play with that, okay? So this is possible because the attribute of p-scale and the normal attribute is transferring into the points. Here you can see with this option mark, it's gonna work, and with this star, you are transferring all the point attributes. So cool, this is working. So after this, I like to recompute the normals again to be sure that the normals are pointing in the right directions. And after this, we're gonna create another noise. So this is gonna be like a noise inside the noise. So it's like the noise inception. So, but this is the same workflow. You create the attribute bob and you put the noise here. So if you bypass, you will see the difference with and without the noise. And finally, we create our final null to say, okay, this is the part of the scattering part. So cool. See ya.